All right, welcome back, everybody. Math 3 AFM. Now, the last time we were together, we were working on sequences. In fact, in Unit 8 is entitled Sequences in Series. So we worked on arithmetic and geometric sequences, and we found that the sum of a sequence is called a series. And we also learned summation notation and things like that. So this video is just a quick review of that. Now there's going to be two separate videos in this piece. So the first one I'm just going to talk about finding nth terms and how to use them, and then finally we'll talk about some sums. Okay, so let's get started. All right, so the first thing we need to look at here is just the definitions that we've come up with so far. Now, again, this is 8.2 and 8.3 in our notebooks or in our notes. And I'll just link this up for you. Now, you have one in your notes if you were there the day we did this. It's called AFM Final Exam Formula Sheet. And this is what you'll use on your exam when you work with these things, okay? So I've linked one in here in Canvas on our home page. Okay, so here it is. There's the formula for an arithmetic sequence and series. And here's the geometric. All right, and we all learned what this notation means. N is the number of the term you're looking for. A sub 1 is the first term. In this case, D is your common difference. R is a common ratio over here if you're talking geometric. This is your sum formula for summing up an arithmetic series, and this is your sum formula for summing up a geometric series. We haven't used this one yet. That will be tomorrow's topic, just this by itself. Okay, so we're just going to get into review today because a lot of people, you haven't done some of the work required behind this, so I wanted to go over it with you one more time. And all right, so let's get started with this. Now, what I've done is I've pulled up my scratch pad here. I call it scratch pad. It's just a Google Doc. Now, the first problem we've got right here is it says find the formula for the nth term. So we're just looking for a formula, and the very first thing we got to do is determine what type of sequence we have. And so far, the ones we've been talking about were either geometric or arithmetic. And if you're looking at this thing here, someone might say, well, it's obviously going down by 4 each time, negative 13, negative 17, negative 21, and that would be correct. So we would say that, and then we'll type some stuff in here, D, the common difference, is equal to negative 4. The first term, I'm just going to call it A. It really is A sub 1. I think it's kind of a headache to put all that subscripts in here the way I'm having to work with this. I'm just going to call it A equals negative 13. All right? And we know... Now, again, we classified it as as arithmetic, and then we know that it's not geometric. That's your very first thing. You got to test these things. It doesn't have a common ratio, so we're going to come down here and plug it into our formula. So the nth term formula would be A. I do need that subscript notation here. And I think it's going to be right there. A sub n. Oh, it didn't work. Yeah, there it goes. A sub n equals. All right, so we'd have negative 13 minus 4 times n minus 1. And that would simplify. I'm going to copy this. I don't have to go through that drawing again. Come on now. And simplified, that would be okay, so to simplify this, we distribute the negative 4. We get negative 4n plus 4. Add that to your negative 13. You'd get negative 9. So we get negative 4n minus 9. And that is my nth. That is an nth term formula. Okay, so What are we using the nth term formula for? Well, someone says, what is the 20th term or the 50th term? So that's what we would use this for. So to find the 20th term, that would be a sub 20. We would say a sub 20. Oh boy, look at that. I can't believe he's doing that to me. Well, the 20th term would be equal to, I'm just going to type it in, -4 times 20 minus 9. So all you're doing is plugging in, and you get that it is, I'm getting -89 here. All right, so that's how you find the nth term formula and what the nth term formula is used for, okay? Now, coming down here to another sequence, I've got another one already planned in here. This one says find the nth term for this particular sequence. Now let's just, for the sake of argument, I know it's a pretty simple sequence and you can probably tell right away what kind it is, but suppose we don't know that. We say, is this arithmetic again? And if it is, it has a common difference. And we go to test it. So 18 minus 6, oh, that's 12. 6 minus 2 is 4. They're not the same, it's not arithmetic. It's just that simple. Then we go to test it for it being geometric, so that means it has a common ratio. 18 divided by 6, and that's 3. 6 divided by 2, that's 3. So this is a geometric sequence. Okay, so we know its formula. We've already found R, we know what A is, so we can go directly to the nth term formula. So let's just type one in here. The nth term formula would be, and A sub n actually, and I'm having trouble with these subscripts, and I'm not sure they're really worth it with all this trouble I'm having. A sub n equals, oh, it worked. The first term times the common ratio raised to the n minus 1 power. So we'll put that in there like this, okay? And that is the nth term formula. And again, the types of questions these things answer are, well, someone asks you to find the, I don't know, the 10th term of this sequence. You might do it with brute force, just multiplying by 3 iteratively, but a quick way to do that is to use this formula. And you know what I'm going to do? I'm going to copy this and paste it back down here. So if we wanted to find the 10th term, to find a sub 10, we're simply going to replace this in, if it will let me do it. Oh, it did that time. With a 10. Replace this in with a 10. And now we know that becomes a 9. 10 minus 1 is 9. And we stick this in a calculator. And I don't have the number in front of me here, so let me see what I get. 2 times 3 to the 9th. I got 39,366. So it would be 39,366. And that's how you use that formula. Okay? And that concludes this part of the video. I'm going to do another piece here in a minute about sums and how we can sum these sequences up. And thanks for watching, and I'll see you just in a minute here.